Hello and welcome. This is the AQA AS Physics Unit 2, June 2015, question 1. Okay, so for part A, we're given this table. Okay, and we've got to decide for each quantity essentially for the velocity, speed, distance, and displacement. Okay, whether they are a vector or a scalar, and obviously you need to tick or cross each box. Okay, now because obviously they can't be both. Now just to remind you, a vector is something that has magnitude and direction, whereas a scalar just has magnitude. Okay, now you can quite clearly see these two are related in the same way that these two are related. In other words, the velocity is related to the speed somehow, and the distance is related to the displacement. In other words, the velocity either will be a vector or a scalar, and whatever that is, the speed will be the other one. Okay, so if velocity is a scalar, then speed will be a vector. Okay, and obviously that applies to distance and displacement. But that spotting that probably wouldn't have helped you. Okay, so I mean it might have done a little bit. Right. Now I'm just going to go through how you get them, how you get a full 2 marks. However, it's not just for 1 mark. It's not just a case of getting them half right. Okay, in other words, 2 right and 2 wrong. It's very specific on how you get the marks for this. But I'm assuming it was fairly easy enough just to get the marks for this. Okay, velocity. Well, is that a vector or a scalar? Well, velocity, you have to think. Well, yes, it's obviously given. It will be given in a magnitude, but does it have a direction? Now, again, if you do M1, velocity is given as a vector. Okay, so therefore it must be a vector in this case. But if you don't do M1, okay, and you're wondering, well, what is velocity? Just think about positive and negative velocity, especially when you're relating it to momentum, okay? Because I'm assuming obviously you're doing the new spec, this is for the older spec. So momentum has a positive and a negative velocity, okay? In terms of the fact that we're looking at the change of momentum, okay? So if you relate to that, then obviously you can spot that velocity is a vector. So therefore it's not a scalar, so therefore speed, as these two are related, must be a scalar. But if you didn't spot that, speed, well, speed is not given in direction, it's just given in a magnitude, so therefore it is a scalar. Okay. Again, in a similar way, distance and displacement are related. One will be a vector, and the other will be a scalar. Okay. So, is distance just a magnitude, or is it given in direction as well? Okay. Well, it's given. You think of this as, I think the best way to describe the difference between these two is the fact that if you went to a certain point, okay, a certain distance away, and then came back to where you started from, the overall distance would be fairly big, okay, whereas the displacement would be 0. So hopefully that makes sense. So displacement therefore is the vector and distance is the scalar. So that would be your answer. Is that right? Yep. Now let me just see what was going on about here. 1 second. See the mark scheme to load up. Oh yeah. By the way, for this particular question, for question 1, most students apparently found the question very easy. However, it's 1B part 2 that students found a little bit challenging, but hopefully it won't seem to. If actually my exam thing, God's sake, work, loaded up, I think it's loaded up. Anyway, I can't quite remember, but as I say, you just have to double check online. So obviously my computer decides to not load up the mark scheme for some reason. But just getting the first 2 right doesn't get you any marks. In other words, yeah, I think it was you need to get 1 and 3 correct, okay. And if you don't get them correct, so you either get your full 2 marks for getting all of them correct, or if you get speed and displacement wrong, then you get no mark. Then you get a mark. But if you get 3 wrong or these 2 wrong, then you get a mark knocked off. Okay, and I think that's going from the fact that these 2 are related, and so are these 2. Obviously, speed does not relate to distance in terms of one's a vector, one's a scalar. They obviously relate in terms of the CVAC equations. But anyway, So hopefully that kind of explains why in the mark scheme it says you need to get certain ones right. You can't just have, you know, a mark for getting 3, because you could spot the fact that they're related in terms of, obviously this is them two are related. This is the vector version of this, and that's the vector version of speed. Anyway, right. So the next bit is again fairly quite easy. It's just about picking information out of the question. Okay, so it says a tennis ball is thrown vertically downwards and bounces on the ground. Okay, the ball leaves the hand with an initial speed of 1.5 meters per second at a height of 0.65 meters above the ground. The ball rebounds and is caught with a travelling speed of 1 meter per second. The first part, all we're asked to do is work out the speed of the ball is just is 1 meter per second. Sorry, show that the speed of the ball is 4 meters per second before it strikes the ground. In other words, we have to show that the speed of the ball before it hits the ground for the first time is about 4 meters per second. That doesn't mean we use it will come to exactly 4 meters per second, because I think my answer, I rounded it up to 2 decimal places, okay, and got it to 3.87. Okay, so obviously that's not 4, but it says is about 4 meters per second, so don't be put off if you don't get 4. Anyway, so let's just notice what we've got. So it's being thrown downwards towards the centre of Earth. In other words, therefore what it's trying to tell you is the acceleration will be positive 9.8 meters per second squared. And there's a height from the floor of 0.65 meters. Okay. Its initial speed is not 0, we're told it's 1.5 meters per second. Okay? That's meters per second squared. And we want to work out the final velocity. Okay, so quite clearly it's just a case of using CVAT equations. And the CVAT equation I used in this case, well, we've got V, we've got S, and we've got A, and we want to work out U. So the only equation really that combines all of them, or the easiest one, the one I thought first, is V squared is equal to U squared plus 2AS. Now if you do mechanics M1, you should be very thankful. In this case you are given the CVAT equations, because in M1 mechanics, for AXL especially, you're not given the CVAT equations. Anyway, so V squared, obviously you put the sorry, I've got this wrong way around, we don't know V, God's sake, stupid. So we want to work out what V is. V squared is equal to U squared, which is obviously 1.5 meters per second, and you square all of that, plus 2 times A, which is this 9.8. I think you use 9.81, sorry. So using M1, in mechanics you only use 9.8, but it doesn't really matter. Okay, so 2 times 9.8 times 0.65. Okay, and obviously you'll get an answer of 14.99. So V squared is equal to 14.99, so therefore V is equal to the square root of 14.99, so therefore the velocity will be equal to, I got it as 3.87 meters per second, which is obviously therefore about 4 meters per second. Okay, so hopefully you can understand where we've got that from. So that was fairly quite easy. Now it's this next bit that people apparently, I mean, if you go through the examiner's report, they do specify, oh, this question was a good discriminator, but so was this one, but so was this one. Generally speaking, it's the latter parts of each question that are the discriminators. In other words, the people who are going to get the A's get the last part of the questions right, the people who are going to get the U's get it all wrong, but obviously they might get the first part. Anyway, right, so I think I'll probably just try and draw a quick sketch without pausing the video. So if you do want to have a quick copy of that down while I just try and load up the examiner's report again. Oh, for God's sake, give up with this. Right, you know what, sack it. Alright, okay, so hopefully you've copied that down. As I say, it's just about using CVAT equations, and the first part was just spotting. Hopefully the first part would have been easy. As I say, when I did this exam, I'm fairly sure I got the first 2 points right, part A and B, because I did this exam last year. But this part, this particular question, I completely shoved it up at the backside, and because I didn't read the question properly. And it's the whole principle, and as I say, so, you know, but obviously that was me in the exam. Okay, so we've got a velocity time graph. Sorry. So obviously we've got 0 velocity here, and I'll mark on the important velocities, but as if you've got the exam up with you, okay, on the screen, you can quite clearly see it's marked out, but I can't be bothered. So we've got this time. The first time that's got a dotted line down is labelled as TA, and it says TA is the it's a time, is it where it hits the ground at time TA. So basically that TA, alright, is what we've just calculated. That TA, sorry, is the time that the ball hits the ground, okay, for the first time. So as soon as it's dropped, as soon as it falls at 0.65 metres, as soon as it hits the floor, this TA is the time that happens at, okay. Now, it doesn't specify, it's not laid out on the graph, but it doesn't really matter, okay. And we've got this other point, okay, which is other time, but it's not a dotted line, it just says on the x-axis it's got time TB, and this time TB, okay, is the time that the ball is caught, okay. So we've got this initial point x, which is at point x, which is at minus 1.5 meters per second, okay, and I know we've calculated the speed as 4 meters per second, but they've taken the positive direction as going up for some stupid reason. Okay, but as I say, it doesn't matter, you just go with it. So what we've got to do, this point here as well is point Y. Okay, and this point Y is the initial, this point Y is the final velocity just before, when it returns to the hand. Now we're told when it returns to the hand, it returns at a speed of 1 meters per second. So obviously if you work out where this Y would be on the Y-axis, sorry, we would have 1 meters per second. Okay, so what we've got to do here is draw 2 separate lines. Now what I originally did, and this is wrong, is I just thought, X and Y, well I'll just connect them up because I haven't read the question properly, so I'll just connect them up. I mean, what's wrong with that? Well, that's completely and utterly diabolically wrong. I can't really emphasise how stupid that is, but that's what I did in the exam, okay? And to be honest, it's just because I didn't really understand the question. And I think again, with AQA, it's the wording. They've started doing this in all exams now. It's not so much the theory that's hard, because they've exhausted as hard as that can be and just made the questions worded as hard, so it messes your mind up in the exam. Anyway, okay, so as I say, this bit is where it hits the floor. Okay, now it rebounds, and it rebounds in the opposite direction. So basically, this is the first half of the journey, and then after this is the second half. We just calculated in the previous parts of the question that it hits the floor at about 4 meters per second. So you would draw a line down, okay, where it hits TA, and then you would just show at that point at TA it's about minus 3.87 or whatever you calculated it to be meters per second. Okay, now that bit's fine. As long as you did that, you would get 2 marks out of the. Sorry, yeah, you would get a mark. Sorry, yeah, mark for just showing that line. Okay. Now, what do we do from here? Do we go straight from this velocity here back up? No, we don't. Because remember, this is it hits the floor, and as soon as it starts moving, it's going to be moving in the opposite direction. So it's going to start moving from a velocity which is greater than 0. Okay? In other words, a velocity which is going to be positive. Make sure I didn't tell you. As I say, actually, it doesn't tell you what velocity it rebounds with. Okay? So what I would do is, and I haven't done properly, especially even in my working out in this one, because I didn't get this question right when I re-attempted this exam. Okay, I still didn't get it right, so, you know, obviously it shows the geniuses from the idiots, and obviously quite clearly I'm an idiot, but anyway, it rebounds, and what you should calculate, you know, you're told it rebounds to a height of, got it, put it down, great, it's in front of my face all along, what you need to do is work out its initial speed as soon as it's rebounded, okay, which is a case of CVAT equations. Now I haven't done the example, so obviously I can't get through it with you now because I didn't realise I needed to actually do it. But again, it's just a case of see that equation. You should realise it rebounds with a speed of 3 meters per second. Okay, but we know it finishes at 1 meter per second, so it's going to have something like that. Alright, so sorry I've not really explained that very well, but it's just because I haven't done the calculation. Alright, but hopefully you can see why that is. Now, let's just say that even if you only drew this line, you would still get at least a mark for that question. And kind of, that question, 3 marks, to be honest, it's only worth 3. I know that's, you could say that's the difference between you grading, you crying. But at the end of the day, you know, you can always pick up marks somewhere else, especially the later parts of this question, which obviously are meant to be harder, but I don't think that much difficult. Okay, so that's the end of part B. Moving on to part C. Part C is a very simple projectiles question. And again, it mentioned in the report that some people tried to confuse it with its acceleration and a load of crud that you didn't. Basically, what it was trying to say is people are making this question far more complicated than it needs to be. So let's just reiterate what it's saying to us. It says, in a game of tennis, the ball is hit horizontally. Now that's the key thing. It won't ever be anything else other than horizontally, because there are equations, especially in the AQA book, that tell you how to calculate something with the addition of gravity. But you don't need to be aware of that in terms of the angles. You just need to simply be aware of the fact that it's horizontal motion. Okay, so anyway, it told us it hits horizontally to a height of 1.2 meters and travels a horizontal distance of 5 meters before reaching the ground. The ball is at rest when hit. Calculates initial velocity when it was hit. So basically what it's saying here is all that the word is quite confusing, I'll admit. So what we've got to do is work out the initial velocity, even though it looks like it's just told us the initial velocity is 0, okay? What that's really saying is, before it was hit, it was 0. We want to calculate the velocity it was hit at. In other words, what's its maximum velocity? Now obviously it's not going to be increasing, but you get the idea. Okay, so what we've got to work out is u. Now, I know it sounded like u was at rest, okay, but that's the initial velocity before it was hit. We want to work out the initial velocity after it was hit, which really is kind of like firing a cannon off a hill, off a cliff even. Okay, so we know, I'm just going to demonstrate this. So the ball is hit from a height of 1.2 meters. Because obviously people have so much time in their life, they want to do stuff like this. Okay, so it travels obviously in a projectile motion kind of way, and we end up with it covering 5 meters horizontally. Okay, so they're the only 2 bits of information that we're given. Okay, we have to work out u. How do we do that? Well, you just have to familiarise yourself with the equations for projectile motion. Now, again, if you do watch the Unit 2 specification overview video, I think I do go over a bit of an explanation on how we come up with the equations for, the horizontal displacement, the horizontal velocity, the vertical displacement, the vertical velocity, etc., etc., and obviously the end velocity. But really, they all come from Suvat equations. You're just thinking, is there an initial velocity in the horizontal direction or the vertical direction? Whichever way you're looking at, and is there acceleration? Now, I just remember the equations, so maybe I'm a genius. X displacement is what we're given. X is equal to ut. The vertical displacement is y is equal to a half gt squared. Okay. So we need to combine these 2 equations because we know x equals ut is giving us the horizontal displacement, which we know is equal to 5 meters. Y is a half gt squared, which is equal to the vertical displacement, which is equal to 1.2. So 1.2 is equal to a half of gt squared. Okay. Now what we want to work out is u. Quite clearly, u is not in this equation, so it looks like that's completely pointless. But in this equation, we have u. But then again, we don't know t. But we know g. The only unknown in this equation is t. Okay, so we can work out what t is from that equation. That's all we can do. Okay, and in this equation, what we need to work out to be able to work out u is t. So in other words, we have to work out t from this equation, sub it into the x equation, rearrange, and get u. Alright, now quite clearly, obviously when we square root we're going to get a positive and a negative answer. But because really you can't have a negative time, okay, obviously it's going to be the positive answer. So as I say, it's up to you how you rearrange this. What I would do is times both sides by 2. So obviously you get 2.8 is equal, sorry, 2.8, what the hell am I doing? 2.4 is equal to gt squared. Okay, so therefore t is equal to the square root of 2.4 over 9.81. Okay, that would give you a time. Okay, I've left it as the exact value it gave me on my calculator, which was 2 root 3 over 7. Obviously you can work out in decimals what that is, but again for accuracy I just like to leave that as the most accurate figure. Okay, so that's equal to the time, remember? Alright, so therefore we have to work out x is equal to ut. So we know x is equal to 5 metres, so therefore 5 metres is equal to ut, and we know t to be this 2 root 3 over 7, okay? So therefore rearrange both sides in terms of divide both sides by 2 root 3 over 7, so therefore the initial velocity comes to 10.1 metres per second. Okay, so hopefully that's fairly self-explanatory for you. Again, basic CUVAT equations. As I say, if you're not 100% sure, I'm going to get x equals ut and y is a half of gt squared, then obviously please do let me know, but hopefully it's fairly self-explanatory. I mean, I just remember these equations. It won't ever ask you to explain why the horizontal displacement is equal to ut, but this just, yeah, I think I'll do a separate video on actually how to explain that. Anyway, so thanks for watching, hopefully it's been helpful, and we'll see you in the next video.